Hey guys, welcome back. In the last lesson, we saw an introduction to the million song dataset. We also looked at how to convert the dataset, which is in HTF5 format, to text tab delimited format using a Java utility program. In this lesson, we'll solve an interesting problem with the dataset. So let me reiterate the problem. Popular artists and their songs are well known, but our goal is to find out less familiar artists but have great songs. This dataset has artists not just from the US but all around the globe. So to take this a step further, we'll also look which artist from this list of less familiar artists is remote compared to all other less familiar artists, meaning who is far away in distance relative to all other less familiar artists. Sounds interesting, right? So let's get to work. In the last lesson, using the Java utility program, we already extracted just the columns we need from the dataset. Now, in our dataset, we have the artist name, artist familiarity, latitude and longitude of the artist, song hotness and song title in tab delimited format, meaning each column value in the dataset is separated by tab. So here's the dataset that you're seeing, and I have already copied this dataset into our cluster. I think we are all set to write a pig script to solve the problem. I have broken down the script into two parts. In the first part of the script, we'll get the artists who are less familiar but have very good songs. We'll use the song hotness to determine whether the song is good or not. And of course, we'll use the value from the artist familiarity column to determine whether the song is familiar or not. Artist familiarity and song hotness are floating point numbers with value between 0 and 1. For example, 0 for song hotness means the song is not that good or hot, but 1 for song hotness means the song is super hot or good. Let's now dive into the script. We'll talk about the jar and the function which we have defined here in a bit. Let's look at the load operator first. Here we are just loading all the columns from the dataset. The contents in the file is tab delimited, which is the default delimiter for pig. So we don't have to specify the pig storage load function to specify the delimiter. Next, we have to discard or filter out any records that has null or empty values. And also we need to only consider songs with less familiar artists and great songs. So here in the filter by instruction, that is exactly what we will do. We will filter out any records with null values, and since we are only interested in less familiar artists, we'll look for records with artist familiarity less than 0.5. And we want to see songs with hotness greater than 0.5. Let's look at the next three instructions together. In the resulting less underscore popular relation, we could have the same less familiar artist with multiple hot songs. And this would result in duplication of data. So let's group by artists and then average the song hotness and filter only records with hotness greater than 0.5. We might lose some artists at this stage, but that is okay. First, we'll do a group by on the less popular relation by the artist information like artist familiarity, artist latitude, longitude, and artist name. So from this group, we'll then project all the artist information and then calculate the average song hotness. So if there is a less popular artist with many songs in the dataset with song hotness greater than 0.5, we'll be aggregating all those songs and we will calculate the average song hotness for all those songs. Finally, in the resulting relation, we will only consider the artist with average song hotness greater than 0.5. Moving on. Remember, this dataset has songs from artists all around the globe. Since we have the latitude and the longitude, wouldn't it be so cool to plot the coordinates in Google Maps? So let's format the output in a way that Google Maps can understand. The format is very simple actually. We are storing the artist's latitude, longitude along with the artist's name, artist familiarity and song hotness in the output. Just simply including all the values in square brackets. That is all. It will be much more clear when you see the output. So let's execute the script until this point and store the output of part 1 in HDFS. I've logged into the cluster and I'm at the grunt shell right. So let's copy the instructions as a whole and let's execute it in the cluster. There you go. This will store the part 1 relation into output songs part 1 in HDFS. Let's wait for the MapReduce execution to complete, and once it's done, we'll review the output. The execution is now complete. As you can see, the pig script read 10,000 records, which are actually 10,000 songs. And finally, we have an output with 22 records, just 22 records. And these 22 records are less familiar artists with hot songs. Let's go ahead and look at the output. Let's bring the output from HDFS. The output is now saved to the local file system, so let's open the file. There we go. Here we have 22 artists. As you can see, this output is formatted for Google Maps. You'll see an opening and an ending square bracket for each record. The first two columns are latitude and longitude, and the third column is the artist name, and the fourth and the fifth column is artist familiarity and the average song hotness. Why do we see Britney Spears in the list? Britney Spears is a popular and a well-known artist, right? Because this artist is taken together. It's just not Britney Spears. Britney Spears featuring Pharrell Williams. Together as an artist, their familiarity goes down to 0.153, and hence they ended up as less familiar. Okay, let's now see how to plot this information in Google Maps. Here I have a small HTML file called unfamiliar-artist.html. Behind this HTML, there is a small JavaScript to plot the data in Google Maps. We need to take our output and paste our output right here for the variable songs_array. The code will now loop through the variable songs_array and will add markers for each latitude and longitude. That is it. Let's open the HTML file in the browser. Let's zoom in a little bit. There you go. You will see that the artists are plotted in maps. Beautiful, isn't it? If we execute the script on the entire 1 million songs, we would have much more result covering a lot of artists. But we executed the script only on 10,000 songs. Still, the result is not bad. We got artists not just from the US, but also from Europe and Africa. And that's pretty good. Now let's look at the part 2 of the script. Here we'll find out the artists who are far away compared to the other artists. Just by looking at the screen here, you probably guess the result. But how do we programmatically find it? Well, we have the latitude and the longitude. Well, calculating the distance from the latitude and longitude, that sounds complicated, right? I understand. One of the reasons we chose this use case for the project is to introduce you to a very important library in Pig. It is called the Datafuel library. Datafuel is an Apache project, and you can get more information about the project right here on their website. This library has haversign function, which will take in a pair of latitudes and longitudes and calculate the distance between the two. At the very beginning of the script, we have 2 lines to register the jar and define the function so that we can refer the haversign function in our script. Now our goal is to calculate the distance between the artists, which means we need to project the latitude and longitude of 2 artists on the same records to use the function, because the function requires a pair of latitude and longitude to calculate the distance between them. How can we do that? We put together a set of slides to understand the solution better. We have already loaded the dataset and filtered out records with null values in important columns. Just for readability, the latitude and longitude is replaced with location. For visualization, let's assume that the resulting dataset in this illustration has only 3 artists, AR, MJ, and XY. Now, let's see how we can find the distance between 2 artists. To calculate the distance between 2 artists, we need to have the latitude and the longitude of the 2 artists on the same record, correct? So how do we project 2 artists in the same record? Very simple, we can cross the dataset with itself. This will take each record from the dataset and cross it with every other record in the same dataset, resulting in 9 records. Let's look at the resulting relation closely. The same artist is listed in both sides as a result of the cross. For example, artist AR is on both sides in the same record. Let's remove those records, because we don't want to calculate the distance between AR and AR, which is the same artist, right? Here is how the resulting result set after removing the common records will look like. And now you can apply the Haversine function to calculate the distance between the two artists. Now we know the distance between every artist from one another. To find the artist who is far away from the other artist, we can simply group the artist from the left and calculate the average distance. So if you group by artist in this relation, all records for MJ, for instance, will be grouped. So for artist MJ, you will have AR and XY grouped. And now you can do an average on the distance column, which will give you the average distance of MJ to other artists in the group. Finally, we order the results set by average distance in the descending order and limit the number of records to 1. Does it make sense? Let's now look at the script. We need the same only hot song artist relation again so that we can do the cross operation. Let's project the same only hot song artist relation again and call it only hot song artist 2. Just to differentiate the columns from the original relation, suffix all the column in this new relation with 2. Now, to bring the two artists together, simply cross the dataset. This will result in a cross product of two relations. Since we cross two identical relations, will result in the same artist crossed on both sides. So we remove those records using the filter by operator. This will result in only underscore different relation. Now we have the latitude and longitude of the two artists in the same record. And we can now apply the Haversine function to calculate the distance between the two artists. Now we know the distance from every artist from one another. To find the artist who is far away from the other artist, we simply group the artist information and calculate the average distance. Here's an easy way to group the columns. Here we are grouping all columns from artist latitude all the way to average song hardness. Instead of listing every single column, you can just specify the starting column and the ending column with the two-dotted delimiter, and this group by operator will group the relation on all these columns. Let's go back to the slide to visualize the average distance calculation. When you group by artist, for instance, all records for MJ will be grouped. So for artist MJ, you will have AR and XY grouped, and you can do an average on the distance column, which will give you the average distance of artist MJ to other artists in the group. And once the grouping is done, we can actually calculate the average distance. Now all we have to do is order the records in descending order based on the average distance, and just list the top one record. And finally, we'll format the output so that we can visualize the result in Google Maps. So let's execute the second part of the script. Let's now execute the store operator to store the output in HDFS. Let's wait for the execution to complete, and then let's review the result. There you go, the execution is now complete. Now let's go and look at the output. I'm going to again bring the output from HDFS. So here is the output. Ryan Benson is the artist who is the farthest artist from all other less familiar artists. So let's copy this output and paste it in our HTML file so that we can visualize the output in Google Maps. Saved it. Now let's go ahead and refresh the HTML screen. There you go. Ryan Benson is an artist from Ghana, and his familiarity is 0.49, but he has average song hardness of 0.57. Pretty cool, right? There are so many things we can do with this dataset, so explore this dataset with your cool ideas. In this lesson, we went over the script to list the less familiar artists with hot songs. And also we saw how to programmatically calculate which artist is farthest from all other less familiar artists. And we also visualized the results in Google Maps. We saw Haversine functions from Datafoo library, which is a very important library to know. I hope you had a lot of fun with this lesson. With that, let's wrap this lesson. See you in the next lesson.